Okay, good afternoon. I'm Brian Motil, and I'm going to provide an overview of Glenn Research Center's ground support facilities, specifically the facilities to support ISS research. I will say these are not my charts. Tom Seignage, who was unable to travel this week, put these together. The best way to find out more detail about any of these facilities is do a Google on either Glenn Research Facilities or GRC Research Facilities. I did it this morning and checked that it does work. And it'll take you to a link that then you can tab in a few and you can get a lot of detail on any of the facilities I'm going to talk about today. And most importantly, at the bottom of each of these links is the contact person that you need to contact in terms of using it. Okay, next chart, please. I am a user, and I have used almost all these facilities, so I do offer that perspective. We have two drop towers up at Glenn. Our larger drop tower we call a Zero Gravity Research Facility. It's 5.2 second. We do draw a vacuum on this facility. We typically drop one payload a day. It's a very large payload. We can take up to 1,000 pounds, and I think the volume is, we can drop the payload can be 38 inches in diameter and up to 66 inches high. The advantage to this facility is that it provides a very high acceleration or high quality microgravity level, 10 to the minus 5 Gs. One of the disadvantages, of course, is that we do have to draw a vacuum to get that level. That takes several hours, so your payload will have to survive that. Currently, we're doing a lot of combustion and flammability testing on this, which of course does need an environment. So we have an enclosure. You can put an enclosure and put whatever atmospheric environment or whatever you need. Another disadvantage to this facility is that you do have to design things to withstand. Typically, we tell researchers it has to withstand up to about 65 Gs. It lands in you can see this vat at the bottom of styrofoam beads. You don't usually see 65 Gs, but we like you to design your hardware to survive that. We do provide the structure and the batteries and the telemetry needed. So all you really have to do is build your payload, and we will help you through that whole process. It's a drop tower is sort of a misnomer. This is actually a hole in the ground. It goes down about, I think it's 432 feet deep, so about the height of an average skyscraper. Next chart, please. Our other drop tower is our 2.2 second drop tower. We do drop it in an atmosphere. We don't draw a vacuum, just down through a chute. There's actually a number of similar type drop towers springing up across the country now that are following a lot of the designs that we use. The payload is dropped within a drag shield, okay, and it falls about 18 inches throughout the course of the drop. So the weighted drag shield and the payload come in contact just before they hit the bottom, which is a giant airbag, similar to the airbag you see in your automobile. You can get a pretty good acceleration level down to 10 to the minus 4. The really nice thing about this drop tower is that you can literally, a researcher can be up on the top, making adjustments to their payload, button up the drag shield, drop it within 10 to 15 seconds. We have a crane that can retrieve this and get it up to a staging level within 5 minutes. So you can just crank through. We advertise that we can do 12 tests a day. We've done a lot more than that. Usually we're limited by the researcher wanting to work on their hardware. But very hands-on, very low-cost way to test things, do initial testing in zero-G. Next chart, please. Okay. We used to operate a zero-G aircraft out of Cleveland. We no longer have it. It was a casualty of one of the NASA budget cuts a few years back. But we do have all the payload processing and support still at Glenn. The aircraft that's generally used for zero-G testing now is contracted out to Zero-G Corporation. And we provide all the support in developing the hardware. We have the structures and equipment you can borrow to fly on this, and we take you through all the safety, developing the safety data package, getting everything ready for you to fly. There is, JSC does still operate a C9, but I'm told that it's very rare that they're going to be flying microgravity missions with that. I think they will still do it. You can petition to headquarters if it's either a sensitive piece of hardware or if you need to vent a hazardous gas like a combustion experiment. I don't think zero-G has that capability yet. Some of the advantages to flying on the aircraft, I'll just mention, is that you get about 20 seconds of microgravity, so you get a little longer duration, but it's really the only platform where a non-astronaut can be there with their hardware and see it running and make real-time adjustments to it. It's also a lot of fun to fly on the aircraft until you get sick. Another advantage is that they can provide partial gravity. They can provide a lunar and Martian gravity level. A disadvantage, if your research is sensitive to vibration, you do get pretty high levels of vibration. You get nothing like the level of gravity that you get in the drop towers. Now, we can free float packages, but what you essentially do is when it goes into zero-G, several people just release the package. It floats until it bounces into a wall, which is about 5 seconds. So you ask yourself, well, maybe I should just go to a 5-second drop tower. People still like the free float because the one advantage there is you don't have to design a thing for 65 Gs either. Okay, next chart, please. Okay, our exercise countermeasure laboratory. This facility basically supports the development and validation of exercise countermeasure devices and equipment. Essentially what it does is it takes the human out of the plane of gravity. This is astronaut Don Pettit testing a treadmill. And it's a great device for basically testing any sort of microgravity exercise equipment. And I'm told, I don't work in this area, but I'm told that a smaller version of this was delivered down to JSC recently and is now being used for people who are bedridden to exercise, and they're having a lot of success with that. Next chart, please. Okay, we have a number of facilities to qual or acceptance test your flight hardware. We have an acoustic test lab which basically can test very low-level noise emissions like fans and that sort of thing in a very good environment. Basically, we can absorb essentially all the sound and don't get any reflection. And we can also measure it at a very high precision. We have an electromagnetic interference lab, EMI lab. We actually have 2 fairly large chambers. I think our largest chamber is 32 feet by 24 feet by 16 feet high. And we have a very large door. It's about 10 by 14 feet. So we can bring in pretty large pieces of equipment and do the full level of testing for both emissions and susceptibility. We have a structural statics lab and a dynamics lab where we can look at induced stresses, static loads, and the stiffness of the hardware. And then we can do a wide range of vibration testing, all the random vibe that you need, short transients, which is essentially a shock load. And we even have the capability to do high temperature testing in this lab. Next chart, please. Okay, we built and operate a combustion and fluids rack that's currently flying on ISS. If you're going to use these racks, we have a ground integration unit available where you're going to have to come in and check all your interfaces. And these facilities can test all the interfaces you'll see on ISS, the hardware, software, mechanical, fluids, everything can be checked out here. In addition, this is available, and it's right next to our Telescience Center. where if there's something that you want to try out with your hardware on orbit, you can come in here with your ground unit, and at least if there's an issue with the interfaces, you can test it here. And it's maintained in a clean room environment. Next chart, please. And then along with that, we have a payload rack checkout unit, which is essentially a facility that provides all the interfaces between the international standard payload rack, which is shown down here. I think it's it back here. Between that rack and the ISS. So you can test out any command data, all these interfaces, the gas systems, vacuum systems, thermal control, all that can be tested here at this facility before shipping to Kennedy. Next chart, please. Now, our Telescience Support Center, it's been up and running over 10 years now. We have the capability to accommodate up to 22 payloads. This summer, we've been pretty busy. We've been running sometimes, I want to say 6 to 10 payloads at a time. What this facility provides is the capability, we provide a minimum of 2 workstations and I think up to 4 real-time video downlinks for a researcher. They can sit on console, they can observe their data real time. We have the ability to command and control the payload from here. We have a secure audio link with the Marshall ISS Ops. So we're constantly in contact with them. And we have the capability, we've done it, I believe, a couple times where the researcher can talk directly to the astronaut. Of course, you've got to get permission, and that's the hard part. Okay, next chart. Oh, and we can transfer this data, or put it on a secure transfer to researchers at their facilities. And finally, last chart, I just want to mention our on-site contractors in Technologies. They've been with us for a number of years now. They're a couple miles from our center, and they have all the facilities necessary to build our payloads. They have clean room facilities, thermal test chambers, and that sort of thing. And it's really nice because they're only a few miles away from our center, so it's easy to ship the hardware there for environmental testing. Most of the engineers and technicians there have 15, 20 years experience in building payloads, so it's a highly skilled workforce, and I think we just renewed their contract for another 5 years, so they'll be with us for a while. And I think that's all I have. Any questions? Okay, thank you.